Okay, it looks like Zoom is behaving itself today. Really slowly, but it works. Except they cut out half of one of my classes. I press record, it'll be 15 or 20 seconds before we start recording. And I'm glad that we started recording for the feedback. That was a distraction. Okay, so we're solving this. So I'm going to use my numbers. So let's say first problem, we have 5 times 7x plus 9 equals. Well, we apply the distributive law. I think pretty much everybody does it. You gotta be careful. 5 multiplies to 7x, 5 multiplies to 9. The 9 and the 7x don't combine in any way because they're not like terms. Okay? In other words, depending on the value of x, 7x plus 9 could be anything. So it doesn't simplify. Well, anyway, 5 times 7x is 35x. 5 times 9 is 45. Now equals 12x. Now, I'm going to write it out like this. I've got 35x plus 45 equals 12x. I'm going to subtract 12x from both sides. I'm not going to write 12x underneath this. I'm going to subtract it from both sides, which is totally equivalent to writing out the negative 12x equals negative 12x, then add it. The problem with that is there's a temptation if you got a negative 12x here, and it happens to be underneath 45, to subtract 12 from 45. And forget about the x or something else. Okay, this makes it real explicit what we're doing, and we don't make that mistake. And if you're making that kind of mistake, like, well, if you're making that sort of mistake, you might want to try writing it out. So you can see it. I'll show you an example of that mistake a little bit later. So you should be able to write them out like this. So I'm going to recommend that when you write it out with the minus 12x here and the minus 12x here and simplify it, you also then off to the side, write it out like this and see that you get the same thing. Okay. Anyhow, what do we have? You can't subtract 12x from 45. But you can subtract 12x from 35x. You got 35 of them, you subtract 12 of them. You end up with 23 of them. You end up with 23x plus 45 equals 0. We didn't have anything but the 12x over here, so when I subtract 12x, and why I subtract the 12x, I don't want to have x's on both sides. And usually I want to get them over here. Nothing wrong with getting them over there as long as it doesn't confuse you. But you just kind of, as a standard, put them over here. It might be a little bit simpler. Okay, so we have 23x plus 45 equals 0. Well, that's then 23x plus 45 minus 45 equals 0 minus 45. Okay. Now we're safe. 45 minus 45 is 0. So we just have 23x over here. So we have negative 45 over here. And now everybody knows what to do. Okay. You're going to get negative 45 over 23. That's a negative 45 over 23. Now that can be written as a mixed number. Okay. That's 1 and 22 23rds. And you want to use the mixed number if you're trying to locate this on the number line. Okay. But if you're an open math ain't going to accept that mixed number. And if you're going to do further calculations with it, you don't want to be using a mixed number in your calculations. The only purpose of a mixed number is to see how big it is, see where it goes in the number. Okay. If you look, if you look at 45 over 23, you know, 45 is pretty close to twice 23. Just pretty close to 2. You can maybe see that. If you have 739 over 14, can't see how big that number is. You might approximate it. It's close to 70, 700 over 10, which would be about 70. That'll be somewhat less than that. So there are things you can do. But you're going to have to change out to a mixed number. Just see how big it is and how much you have left over. Okay. Okay, so we have this so that this is the answer over math wants to see. It's the first answer I want to see. Although I probably wouldn't count it wrong if you gave me this number. But I want to see this because it's a number you need to use if you're going to do further calculations. If you need to put it in a graph, then you're definitely going to want to get the mixed number. Okay. So mixed number doesn't hurt, but first the improper fraction. Okay. Well, that was pretty straightforward. I think everybody's in pretty good shape here, but we want to be careful. And again, I kind of like the linear notation because of the mistakes I see some people make using 2 lines. Okay. Usually, judge, whatever gets you there is okay. It's valid either way. Be careful. Okay, so now we have a over 7. That's going to be 5 sevens plus 7x over 11 equals -9. I think people want to put things over common denominators. That's great, because you do need to know how to do that. Okay, but in an equation, you don't want to do that ever. You never want to put things over common denominators. You want to get rid of your dangleable denominators, okay? Because they're a pain. And it's really easy to make mistakes. You're 10 times more likely to screw it up if you try to put everything over common denominator. There's so many ways you can screw it up. And that applies for me too. I'm trying to do these. I don't want to screw it up. I'm certainly not going to use common denominators, even though I do it pretty efficiently. It takes longer, takes more steps, and it's just harder to get it right. So if you know how to do it, that's wonderful. Do it when it's appropriate. When you're adding 2 fractions, that's exactly what you have to do. Okay, so what we do is we multiply 7 both sides, because if this is equal to this, 7 times this is equal to 7 times this. It's that simple. That's why we can multiply both sides by the same number, as long as that number isn't 0. You multiply by 0, we lose all our information. We just get 0 equals 0, and there's nothing we can do with that. Okay. Now what do you do? It's not relevant to the solution of the problem. Okay. So we multiply by 7. We do it in steps. We see a multiplication here. First place, these 2 things don't combine. This has an x on it. Its value changes as x changes. And this is fixed. So we can't combine this. Now you can combine them as fractions, but we don't want to do that. So we have 7 times 5 sevens plus 7 times 7x over 11 equals, well, this is -3. Now I like to put the 7 over 1 and the 7 over 1 until people are really, really comfortable with fractions, which is never. Okay. And we see that we could interchange the 1 and the 7 because the numerators would still multiply to the same thing, the denominators would still multiply to the same thing. And then we'd have 7 over 7 times 5 over 1, and that's just 5. Better to think that through and get in the habit of seeing that than it is to draw lines through these things. Okay, I'll see people draw lines through these 7s and this one and go on. Okay. And that's a mild form of the mistakes I see people making with cancellation. You need to understand the cancellation is canceling factors. You just don't get to take this 7 and use it to wipe out all the other 7s in the equation. Okay? Doesn't work. But here it does. And there's a reason why it does work anyhow. This is then going to be 7 times 7 is 49 over 11, and that's negative 63. Okay. And there's an x in there. It's 49 over 11 times x, or 49x over 11. You probably want to see me type 49x over 11. Notice I tried hard to lose my x there because I was concentrating on something else. I see y'all doing it too. Of course, I should be doing it. Okay, so makes sense. 7 times 7x is 49x. 1 times 11 is 11. Now what do? Oh, got to blame the denominator again. Okay, now we could have gotten rid of both of them at once, but multiply both sides by 77. But you got to do it in 2 steps until you get used to using a common denominator, and it's okay. It gets it done. And I think it's simpler, but more work to do it in 2 steps, and that's what I'm going to do. Okay, so we multiply both sides by 11. Okay, 11 times 5 is 55. We got a fraction, so I'm going to write this 11 as 11 over 1. I think that's 693. Easy. 10 times this is 630. 11 times is another 63. 30, 63 is 93. Okay. And it's fine. I mean, if you need to use your calculator to multiply that out, it's okay. Although you really should do it by hand, unless it's really nasty. That was pretty easy. And it's important to do things by hand. Okay. 55 plus. Again, switch the 1 and 11, because when you multiply fractions, you multiply the numerators and you multiply the denominators, and it doesn't make a darn bit of difference if the 11 is here or here. You're going to multiply by 1, right? But if it's here, you see it's 11 over 11, which is 1. And you see you got 49x over 1, so it's just 49x. You don't have to cross anything. Okay, so now it's going to be 55 plus 49x. We're going to subtract 55 from both sides. Okay, on this side, you're going to get, see there, 55 minus 55, that's 49x. And you're going to get negative 748. Then you're going to get 49x over 49. That's a step I skipped over here because I didn't have room to do it. I think everybody's pretty good with that step. We'll go on skip. Okay. And then 49 divided by 49. It's like 49 over 49 times x over 1. Okay. I want to kind of think that. You're not thinking that. So actually, for 448 over 49. No, that was negative 700 and never mind. Yeah, it was negative 749. And we'll divide this by 7, divide this by 7. Go into 749. It doesn't go into 748. The only thing goes into 49 is 7. Okay. 7 times 7 divides 49. Nothing else divides 49, because 49 is 7 times 7. There's no number that divides 7. Now, you can write that as a mixed number. Okay. It's going to be in the order of 15 a little bit. Okay. You know how to do that. The other thing that you really want to do when you're learning this stuff, if you're like doing open math and you're not getting the right answer every time, get the right answer, okay, you probably did it right. You get the wrong answer, well, first you're going to get dinged. If you don't correct it, even if you do correct it, if you do correct it, you get some credit. Okay, you plug this back in here and see if you get the same thing in this, see if you get -9 on this side. Just like will be -9 no matter what. Okay, and if you're not doing the check, selling yourself short. It takes extra time. You got to balance your time. But if you check your solutions, get used to finding your errors, and you start correcting them. If all you know is, nope, that was wrong, I put in another one, and make the same mistake again, pretty soon you're losing a lot of credit. And you're not learning what you learn. It takes extra time to plug a wrong solution back in, especially if it's a little bit messy with these numbers, although it's not that hard. You know, with a calculator, you would use a calculator to plug this in. Okay. You're perfectly valid. I'd use a calculator. Okay. I'm at the limit of what I can do in my head, and I probably made a mistake anyway. Doing this in my head. Actually, I could. Since I have a 49 behind there, I have a 7 later. So I end up with a 7 here, and I'm going to divide by 11. Okay. Still, I don't want to do it. I don't want to do that much arithmetic in my head. It's not reliable. Quick to punch it into your calculator and see if it's right. Then if it's not, go back and see what you might have done wrong. You want to be able to do this and do every step and understand why you're doing every step. Okay. So, work on that. Now the sheet I just handed out offers plenty of practice with some solutions. Okay. And hopefully that's going to be useful to you. Now, we'll talk about the sheets. Okay. What about this? Okay, so we got 0.03 x plus 7 equals 9. Okay. Now it's real easy to subtract 7 from both sides. You get to, and it's pretty easy to divide by 0.03. But anytime you have decimal numbers, you can serve them out. All I have to do is multiply both sides by 100. What's 100 times 0.03? It's 3. Okay. Now you really need to understand that about decimal numbers, since you've done way too much with the calculator and way too little with your hands. Not your fault, but that's something you learn in fifth grade. Okay, got to relearn it. Well, then relearning. It's only 5th grade stuff. You learned it once. You're doing stuff way harder than that. Get it right. Okay. So anyway, you do 100. Times 0.03x plus 7 equals 100 times 9. So that gives you 100 times 0.03 plus 100 times 7 equals, we'll just go ahead and multiply that. Now it's 900. It's really easy to multiply by 100. And if I have 0.037298, I could multiply by 1 million. Okay. It's real easy to multiply by 1 million. You can just have the right number of zeros, and for decimals, you just move your decimals over. Okay. Look at it. This gives you 3x plus 700 equals 900. I'm not going to finish that. I don't want to solve the. Okay, you know how to finish that. All right. Now, this package that I handed out to you, and you know, I've got a program that spits these things out. Okay, you've got it. You should have at least 3 versions. Now, maybe you have the tail end of one version, and then you have 2 other versions and part of another one. But in all, there's 6 problems in each version. You should have at least 18 problems. 3 of one kind, 3 of another, and so on. If you pull that packet out, go down to where it says version. Let's find the first version you can. And then count down. PB means a problem. Okay, count down to the 3rd problem, when doing the opposite side. Actually, the 4th problem. Okay. So locate that. I'm going to tell you a little bit, and I'm going to ask you to write out those expressions, okay? Because those expressions aren't in your standard mathematical notation. You don't have your numerator up top, your denominator in the bottom. Okay. Took me a good bit of time to figure out what I wanted to put on this and execute. Okay. Not that long, it took me not quite a full afternoon. If I'd have tried to put it in LaTeX, my LaTeX editor is very picky. It would have taken me another day to get all the errors out of it. Okay. Errors are in everything. And I don't have that kind of time. I'd rather do something productive than put things into unnecessarily pretty notation. So we've got to be able to interpret things like this. So if you write down this. What's that mean? But by the order of operations, it means you do the divisions first. If there are multiplications, you do those. You do multiplications and divisions in order. That's your order of operation. Okay. You got to do multiplications and divisions before you do any additions or subtract. So using that, write this out in standard mathematical notation. Now, for example, if I have, what I mean is, you write this as x plus 3 over 6, right? If I had x over 5 plus 7, well, actually, you do the parentheses first, right? Parentheses are a group. And let's say it's over 5x plus 7. So I'm not tempted to add the 5 and the 7. How do you write that? It's your numerator. It's divided by this. That makes it into the denominator. It's x over 5x plus 7, right? That's what it means. It means x is divided by whatever's in the parentheses. Okay. Incidentally, if you're typing stuff in to a computer algebra system, this is how you have to type it. You can't type it like this. Okay. Now, there are often ways you have an editor that'll make it look like this, but it's much quicker just to type it like this. So you're wasting a lot of time if you don't know how to type it like this. All right, so write out. What's that expression? Hopefully everybody will write it out correctly, but usually there are going to be some mistakes. Okay, again, I asked, what's the denominator here? Is it 3 or is it 3 plus 7? It must have said, well, it's 3. That's why everybody wrote it out. Okay. But we want to make sure we understand why we write it out. If we do the 3 plus 7, well, we did the addition before we did the division. You got to divide 5x plus 3, then add 7 to the result. Okay. So this means what's the words here? By 5x by 3, then add 7 by the order of operations. You do multiplication before you do addition. Okay. So there's a reason why we write that out. I kind of copied you here. So I'm not sure whether you're doing it because you just look at fractions and you're seeing fractions, or because you understand the rules. Okay, the rule is got to do the division before the addition, so the 3 never gets added to the 7. 3 gets used up when you divide it into 5x. It doesn't get added to 7. So we get 5x over 3 plus 7. Now what? What happens here? Does that 4 get added to 5? No, that 4 is part of a division, and that 9, so that 5 is part of a division, right? So you got to do 12 divided by 4. Then 5 divided by 9. You can't add this to this. Okay. Because again, this is part of a division, and this is part of a division. You can't add. Can't add. So that's the main thing you need to understand. So let's look at that fourth problem after conversion. Everybody kind of pull out that fourth problem and circle, just so I make sure everybody's got the fourth problem. If I'd have been thinking, I would have numbered them, but I was too busy trying to get errors out of it and making sure the solutions were accurate. Solutions would take a little time. Okay. Here's the equation. I've got denominators. I got a denominator x, I got a denominator 7. We chose multiply both sides by your denominator. Many of you tried to do too much in this one step, and that almost always at this stage leads to an error. Okay, so I just write out as I did in this other problem here. Yeah, like this. Okay, what I do here? Multiply both sides by denominator, right? Now I do that, and I get 7 over 1 times 8 over x. When I multiply the fraction by a number, I'm going to want to put the 1 there. Okay, I know I can skip it, but not everybody does at this point, and it leads to errors. So let's do that. And then it's 7 times 4 plus 7 times 2 sevenths. And I want to write that as 7 over 1 times 2 sevenths. I'm sure I see what's going on. Now at this stage, 7 over 1 times 2 over 7 is the same as 7 over 7 times 2 over 1, because the denominators are the same either way. Either way, I get 14 over 7, which of course is just 2. Okay. Now my whole goal was to get rid of the 7 and that denominator, and this does it. This 7 over 7 is 1. So this gives me a 2. And then I've got 56 over x plus 28. Well, now the 28 and the 2 add up to 30. So I could do that, since I got an obvious addition, or just multiply through by x, which is going to be my next necessary step. Now I say, if you see a denominator, don't stop and do anything else. Multiply both sides by that denominator. So that's what I'm going to do. Okay. It'd be harmless to add those to get 30 and do another step. I'm going to do it right away because I want you to get in the habit of doing it right away. It makes something complicated into something very simple. Okay. So I do X and I write it out. I don't try to write out what the next step is going to be. I just go ahead and write out whatever I have. And I just write this expression exactly as it is. I write this exactly as it is. And then I multiply through. I'm going to have X times 56 over X, but I know that this is a fraction, so I'll put the X over 1. But to be sure to see why the X goes away. And then it's 28X. And then it's 2X. And it's 35X. And I'm almost home free. As soon as I say that, well, X times 56 over 1 times X gives me the same numerator and denominator as X times 56 over X times 1. Right, this is X over X times 56 over 1. X over X is 1, 56 over 1, 56. So I get 56, and I don't have to worry about crossing out X's. Cross this one out, I cross all these. I cross the X over here out. Okay. Cross the X's in my whole textbook out. Which doesn't make any more sense than some of the cancellation I see. So we want to understand why the cancellation goes. Okay, so we get this, and then we get 30X and we get 35X. Okay. And then you're home free. That's a really easy equation. Right. Do with denominators. Okay, now people that did the homework did fairly well on it. But you still got a ways to go and solve linear equations, and you can't let that get in your way. You just can't let the arithmetic and algebra get in your way. So coming back to the problem I gave you, problem after the one that we just looked at starts having X squares in it, okay? And unfortunately, we didn't have time to talk about what you do when you have X squared. So you're gonna have to look at open math. But this is going to give you practice on solving problems of that nature. And I recommend you use this for practice. Okay, you got at least 3 versions, 6 problems with hints and solutions. You can see if you're getting it right. If you need the practice, be sure you practice. Okay, it's not required, it's optional, but it is required that you know how to solve linear equations and then kinds of equations you run into in the homework. Okay. Okay. So as I said, this is where we're starting the 161. Put that on there so I can easily find it. Because then I can put a note on the video that tells you where one side starts and never stops. Okay. Actually, one stops and never starts. Temporal. Okay. So we want to find out the inverse of this. How we did this. Okay. We did an example in class. I think we did it okay in class. Somehow lost track of it. There's people. Most people. So the thing I told you in class is, first of all, we looked at the graph. I said to get the inverse function, you switch columns, and you graph it, and the graph's going to look like sort of a reflection across the diagonal line of the original graph. That's the first thing you need to understand about inverse functions. You're switching X and Y. Now you do it with graphs, that's really easy. If you got a table, you can switch the columns, and you can plot the, you can draw the curves. Nobody has trouble with that. Okay. At least not now. You would have at the beginning of the course. I think we've nailed that one. Okay. And we're doing well with that aspect. But you know about switch X and Y, we saw switch X and Y in the graphs. Then the next step is solve for Y. Okay, so I'm going to do this pretty quickly. And then I'll spend a little more time on this because the algebra there is pretty tricky. Okay, so the first one, f of x equals 3x minus 9. So y equals 3x minus 9. The reason it should be obvious, if you understand what we did with the graphs, we switch x and y. We get x equals 3y minus 9. And then we solve for y. Well, we're going to get x plus 9 equals 3y minus 9 plus 9, not x times 9, x plus 9. Okay, you got to write out your operations. You got to write them out a step at a time. Then 3y minus 9 plus 9 is x. It is 3y, and that's still equal to x plus 9. We haven't done anything to this side. You don't try to do all these three steps at once and then say what you think y might equal. Maybe you do that and then check it. Yeah, you think y is equal to this, we'll plug it back in here and see if that works. Okay, so you want to skip 3 steps, make sure you plug it back in. And if you don't get the right thing, teach you a lesson. Skip steps. Okay. So then we do plus 9 over 3 equals 3y over 3. Y equals x plus 9 over 3. So f inverse of x is x plus 9 over 3. Verify, which means we do f of f inverse of x. Question mark, is that equal to x? How do we do f of f inverse of x? We say, well, f of x equals 3x minus 9. So f of f inverse of x. Very, very simple step. People are trying to do all kinds of things with this because they've got information about f inverse of x and they want to put that information in. Don't put that information in. Use what function notation tells you, which is that whatever goes in here replaces x. So whatever's in here replaces x. You don't care what the function is for this at this point. You don't want to confuse yourself with the fact that f inverse of x is x plus 9 over 3. I don't want to see any 9s or any 3s over here, except the 9 is already there. Okay. And it's not that I don't want to see it. You know, what I want to see is a correct solution that's validated. You don't want to see it because you don't want to confuse yourself with it. Okay. Yeah, so f inverse of x is 3 f inverse of x minus 5. Period. That's the end of this step. You don't do anything more with it. You then say, well, okay, that means that f inverse of x equals 3. Now we can use what we know about f inverse of x. We don't use it here. We don't use it here. We use it here where we finally have this. We're secure with this. If we understand, again, this replaces X, so this has to replace X. That's all we have to know. Then we can plug in, because of course we can substitute equal things for each other. F inverse of X is equal to this, so certainly we can put the X plus 9 over 3 here. And then we write everything else out. So all we've done is, well, we've got F inverse of X, we've now got X plus 9 over 3. Okay. Well, what's 3 times X plus 9 over 3? Well, I could have written that as 3 over 1 times X plus 9 over 3. So I can see that the product of my numerators is 3 times X plus 9, and the product of my denominators is 3, right? Now, if I put the 3 here and the 1 here, my numerators still multiply out to the same thing. My denominators still multiply out to 3. If I put the 3 here, 3 can be divided by 3, that gives me 1. We're going to think through that, make sure that you don't misuse that 3 or use it twice. Because so one person tried to multiply it by this, then they thought that this one would go away. But they've already used the 3 to multiply, it doesn't work because not thinking this, okay? Not thinking of it. Another way to do it, of course, well, I'm saying do it this way. See that, you're not likely to forget it, you're not likely to mess it up. So anyhow, this is going to end up equaling X plus 9. 3 times X plus 9 divided by 3. 3 actually divides this 3. And you get X plus 9. And then proves this part of it. Now you've got to also it works the other way. If you do F inverse of F of X, you still get X. Okay. You kind of see how that's going to go. F inverse of F of X, you're going to put F of X up here where X is. You're going to have 3x minus 9. It'll be 3x minus 9 plus 9. That's just 3x divided by 3 is X. That's even easier than this was. Now you probably didn't understand all that, unless we already looked on it. Okay. All I'm saying is you just do the same thing here. You follow the same steps. One step at a time, one thing, one simple thing at a time. Make sure it's a valid thing. Figure out what it's just, and you've got 12 rules. That's all. All the rules. I think we can reduce down to probably reduce it down to less than that. Okay. It's like a game. You have 12 rules in the game, you learn to follow them. And you make sure that you are following them correctly. Otherwise, red ogre gets you or whatever. Okay. Otherwise, you make a mistake. Okay. Now, this one is tricky. So you got it's tricky, but you have problems like this. Okay. Then this equals this. So well, you switch X and Y and you get X equal 2y plus 3 equals Y minus 1. Now you solve for Y. Well, let's write it out again. Reflex, and this is why I want you to really pay close attention to most of what we did in the preceding support class. Okay. We multiply both sides by the denominator. Now there's a caveat there. The denominator is not allowed to equal 0, so we got to make a note that y can't equal 1. And I'm not going to bother with that right now. Okay. Just concentrating the algebra solving this. What I just said is important. I don't want to distract from this text. There's the step. Now, on the left, I wrote y minus 1. On the right, I wrote y minus 1 over 1. Because y minus 1 over 1 is exactly the same thing as y minus 1. I put the 1 here to remind us of what's going on with the fraction. Okay. And we understand, as before, if I switch the 1 and the y minus 1, it makes no difference in the product. Numerator times numerator is still going to be the same. Denominator times denominator is still going to be the same. But now we see that y minus 1 is divided by y minus 1 for sure. We know that gives us 1. So we know that we can now write y minus 1 times x equals 2y plus 3. Okay. Now, it really would have been okay to go ahead and use the distributive law to multiply this out. In this step, but I chose to do it in another step. Be really kind of literal about what I'm saying is one step at a time. Okay. It would have been okay. But, that gives us xy minus x equals 2y plus 3. Okay. Well, I'm probably going to want a little more room than I've got. So let's go ahead and repeat this on. So we've got question at this stage is, how do you solve for y? This is where it gets a little bit tricky. Well, one thing you know, if you want to solve for variable, you pull everything with that variable onto one side of the equation, put everything else on the other side, right? So if it's got a y in it, it's got to come over here. If it doesn't have a y in it, it's got to go over there. You have to do that using the rules by adding or subtracting something from both sides. We don't need any multiplication to do it in this case. So do the 2 steps. But x, y minus x minus 2y. Well, you know, I've got this side, and I've got a minus 2y. I've got this side, and I've got a minus 2y. Okay. I'm getting to where I really don't like the idea of writing the 2y down here and the 2y down here, because people will try to add a 2y to a 7 and get 9y. I've seen too much of that. Okay. That could still be done here, but it's a little less likely to happen. So I'm going to start writing things out this way. Okay. The other way is valid. I didn't dislike it that much. Nobody did that 50 years ago, but that's okay. In many ways, it's an improvement. There are a lot of advantages to doing it, but I'm seeing too many mistakes as a result. Okay, so we're going to write it out this way. Don't make mistakes, write it out the other way, just make sure you don't make mistakes. We'll write it out both ways and make sure they agree. That's even better, because then pretty soon you get used to the pitfalls. There aren't that many of them. And you start avoiding them, and then it doesn't matter which one. Okay. Anyway, I'm going to write it out this way. Okay. So now I've got all my y's over here, but I got this x. Well, let's write out more steps really necessary. And here's what we've got. Okay, we eliminated 2. We took 2 steps, we eliminated 2y. We took 2 steps to do it. But we got time. You take a test, I'm not gonna time. Okay, you probably, want to get out of the testing center before you start, I guess. Some people cut so should have all the rest not really. Okay. Some people spend a whole lot of time in tests. You want to be able to do it relatively efficiently. You don't have to rush. It doesn't take long to write out 2 steps where you think you could do it in 1. And it's safe to do it in 2 steps. It's safe. Okay. You got x, y, minus x, minus 2y equals 3. We don't want x there, so we add x to both sides. And then we are confident that we have xy minus 2y equals 3 plus x. And now we're almost done, but we usually don't see it. Okay. And I've said that to at least one person. Yeah, I remember the first time I saw this, I had to beat my head against the wall a couple of times before it occurred to me what you do. I don't think anybody had to tell me. But it probably would have been better from the wall if somebody had. Okay. I really, when I did algebra, I break pencils. Okay. It's at the desk. And there's a window outside. I really want to be outside playing football instead of doing algebra. Even though I didn't mind algebra. Just like football. That's better at algebra, though, so it's probably a good thing. Okay, so we got this. What are we going to do? Well, use distributive law backwards. Okay. I could write this as y times x minus 2. That's called factoring, and you've certainly seen factoring. If you're in here and haven't seen factoring, you're gonna have to spend a little extra time getting good at factoring, okay? I actually think factoring is of limited use in the real world. Okay, because you almost never see any real world problem with factors. But in algebra, and sometimes it's always you have to put that. Also, it explains why certain things work and important. So I'm not against that. Okay, you got this. How do you solve this? Well, whatever is multiplied by y, which is x minus 2, divide both sides. Well, y times x minus 2 over x minus 2 equals 3 plus x over x minus 2. Now that can be written as y over 1 times x minus 2 over x minus 2, which confirms that this is just equal to 1. Not just equal to y because you want to believe it's equal to y, right? It's equal to y because the rules tell you it's equal to y. What you believe, what you think you see when you look at something doesn't count unless it follows the rules, right? Okay. There you have it. So the f inverse of x is 3 plus x over x minus 2. Now there's some randomization in the tests. When we get to a test. Okay. So you're highly likely to see something like this. It could get more complicated. I can make it more complicated, but if you do this with an inverse function, I'm satisfied. Okay. And there are other inverse functions that we encounter later with exponential functions and stuff, where the algebra is much simpler. This is about as nasty as the algebra is going to get with inverse functions. Okay. And it's not that bad, but you have to know the rules. You have to know why we're doing each step. Okay. And then you can do f of f inverse of x. So I'm going to do that. I'll just do an f of f inverse of x because can't justify the time to do the F inverse of F of X. It's usually exactly the same type of steps. Okay, so what's F of F inverse of X? Well, F of X is 2x plus 3 over X minus 1, right? Well, first of all, let's write out what we're going to. F of F inverse of X equal to X. Okay, well, let's review. F of X equals 2x plus 3 over X minus 1. I really recommend you write out this step. Imitate the steps that I'm showing you. Don't skip. If you're not imitating these steps and you're not getting the right answers, you really need to go back and imitate the steps. Okay. So at this stage, you can ask me, well, what's F of R bar? Well, it's 2 R bar over R bar minus 1, isn't it? Because if you replace X with R bar, you got to replace X with R bar. Well, if you're replacing if you're replacing X with F inverse of X, you're going to replace X with F inverse of X. And you're going to write 2 F inverse of X plus 3 over F inverse of X minus 1. Okay. Well, then in the next step, this is equal to 2 times, and this one is really tricky. F inverse of X is 3 plus X over X minus 2. Plus 3. And that's divided by F inverse of X minus 1. So we're going to have another 3x, 3 times. Right, 1 or minus 1. I can start to write it myself. I'm doing it. Say it and I'll do it. Okay. Minus. Okay. So that all matches up. At this stage, you say WTF? What's this foolishness? Okay. What sort of crazy thing is going on here? What are we going to do with all this? Okay. It's really a confusing moment. Okay. Well, look at the numerator. Fraction, it's better than denominator. Okay. Turns out I could put all this over common denominator. I could do 3 times X minus 2 over X minus. Okay. And this, and that would be okay. But notice that the X minus 2 here is the same as X minus 2 here. So if I multiply the numerator of this whole thing by X minus 2 and the denominator by X minus 2, let's see what happens. Okay. Now, if you look ahead, that means I've got to multiply all this by X minus 2. So maybe I've got to put this in parentheses and remind myself it's all going to be multiplied by X minus 2, right? Which means I'm going to be multiplying this by X minus 2. Well, the X minus 2 can be lined up with this X minus 2. Goes away. Yeah, by the rules. And same thing's going to happen down here. You're going to have a simple fraction. And hopefully the numerator will equal the denominator. Well, the numerator will be x times the denominator, so it's going to reduce down to x. Now, I guess. One more space. And so. Bring this up here. This is going to equal 2. I'll write it out, 2 over 1 times 3 plus x over x minus 2 multiplied by x minus 2. I'll make that x minus 2 over 1 because it's a fraction. So all I've done is I've taken this and I've put ones under everything that doesn't already have a denominator. So I've got my 2, and I've got my 3 plus x over x minus 2, and I've multiplied it by x minus 2. So far I'm using the distributive part. Well, then I got to do plus 3 times x minus 2, right? No denominator involved there, so we don't have to do it 3 over 1 or anything. Okay. And over here I do the same thing. I'm going to have this numerator times numerator, distributive part. Denominator times denominator, distributive part. Now, I see that my x minus 2 will be lined up with my x minus 2. I can switch the 1 and the x minus 2. So x minus 2 go away. The math will tell you just cross them out. Because they're factors. You really understand what factors are. It's not a bad way to do it. It's really the way you do it once you get good enough with your algebra. Okay. Most of you aren't there with your algebra. So you make sure that you see that this can be rearranged with x minus 2 over x minus 2. And now we can say that that's okay. Well, let's see. Now my denominator would be 1. I just have 2 times 3 plus x plus 3 times x minus 2. And down here, again, the x minus 2 is to be lined up, divided by each other. And I end up with 3 plus x minus 1 times x minus 2. Well, now I can use the distributive law here. 2 times 3 plus x is 6 plus 2x. 3 times x minus 2 is 3x minus 6. And this is divided by 3 plus x minus x plus 2. Negative 1 times x is minus x. Negative 1 times negative 2 plus 2. Now the 6 and minus 6 add up to 0. So I just get 2x plus 3x. That's 5x. And down here in the denominator, x minus x is 0. I end up with 3 plus 2, that's 5. 5x over 5, I think is going to is equal to x. And that's what we wanted to show. So it was easy. Right? No, it's a lot of steps, and you have to know steps, and you have to practice a lot. Okay. And that's a little bit challenging.